Imagine this, a colossal wanderer from the depths of interstellar space, hurtling toward our sun at over 130,000 miles per hour, carrying secrets older than our solar system itself. What if this isn't just another chunk of ice and dust? What if it's a messenger from another star, challenging everything we know about the cosmos? Welcome, friends, to the story of 3I/ATLAS, the third confirmed interstellar object to grace our skies. Stick with me as we dive into this cosmic enigma, blending hard facts with the wild wonders of speculation. If you're as hooked as I am, hit that subscribe button now and turn on notifications. You won't want to miss the updates as this mystery unfolds. Picture a quiet night in Chile on July 1st, 2025. Astronomers at the Asteroid Terrestrial Impact Last Alert System, or ATLAS, a NASA-funded telescope network, spot a faint speck of light moving against the starry backdrop. At first, it's just another blip, designated A11PL3Z. But as data pours in, the excitement builds. This isn't a local comet from our Oort cloud. Its hyperbolic orbit screams interstellar origin. Confirmed within days, it's dubbed 3I/ATLAS, the 3I marking it as the third such visitor after 1I/Oumuamua in 2017 and 2I/Borisov in 2019. Factual observations paint a clear picture. At discovery, 3I/ATLAS was about 4.5 astronomical units, AU, from the Sun, roughly 420 million miles, cruising at 61 kilometers per second relative to our star. Pre-discovery images, dug up from archives like those from the Zwicky Transient Facility, trace it back to June 14th, 2025. Telescopes worldwide jumped on it. Hubble captured its teardrop-shaped coma on July 21st, while the James Webb Space Telescope, JWST, scanned it in infrared on August 6th. These tools revealed an active comet with a bright cloud of gas and dust enveloping a solid icy nucleus. But here's where the drama kicks in, smoothly transitioning from routine detection to riveting intrigue. Unlike its predecessors, 3I/ATLAS arrived during a golden age of astronomy, with advanced instruments ready to dissect it. No leaks or hidden images here. Everything's out in the open through peer-reviewed papers and public NASA releases. Yet the sheer timing feels cinematic, a rare cosmic event unfolding right now, in 2025, as if the universe decided to drop a blockbuster plot twist on us. Now let's zoom in on what this intruder is made of, because the details are nothing short of mesmerizing. Factually, 3I/ATLAS is a comet, complete with a nucleus estimated at up to 5.6 kilometers, about 3.5 miles across, though some analyses peg it larger, around 7 miles in diameter, making it the biggest interstellar object we've spotted. Its coma, that glowing envelope of sublimating ices, spans up to 18,760 kilometers and grows as it nears the Sun. Spectroscopic data from JWST and the Very Large Telescope, VLT, confirm it's rich in carbon dioxide, CO2, with emission rates around 129 kilograms per second, alongside water vapor, 6.6 kilograms per second, carbon monoxide, CO, at 14 kilograms per second, and carbonyl sulfide, OCS, at 0.43 kilograms per second. Cyanide, CN, and atomic nickel, Ni, vapors have been detected too, at rates of 17.6 grams per second and 4.6 grams per second, respectively. Interestingly, no iron Fe vapor shows up, which is unusual for comets, but verified through multiple observations. The surface appears reddish, likely from irradiated organics, and polarimetric studies show high negative polarization, hinting at a mix of icy and dark materials similar to distant trans-Neptunian objects. Observations from the NASA Infrared Telescope Facility in Gemini South reveal water ice in the coma, and test satellite data from May to June 2025 caught early activity at 6.4 astronomical units, suggesting volatiles like carbon dioxide or carbon monoxide sublimating before water does. This is all grounded science. No speculation needed to appreciate the pristine nature of this relic. Yet to amp up the drama, consider this. Initial reports noted a lack of visible tail or strong gas signatures, leading to whispers of anomalies. High-resolution images later showed an anti-tail, a sunward-pointing dust feature that's actually an optical illusion from our viewing angle, where dust from earlier ejections appears to point toward the sun. Fact: this happens in some comets due to perspective and solar radiation pressure, but it adds that edge of your seat tension, doesn't it? As we transition to its path, imagine this ancient body, possibly 7 to 14 billion years old from the Milky Way's thick disk, older than our sun, carrying untouched chemistry from a distant stellar nursery. Hold on tight because the path of 3I/ATLAS through our solar system is where the story turns into a high-stakes thriller. Factually, its orbit is steeply retrograde, inclined about 5 degrees to the ecliptic, with an eccentricity of 6.14, far beyond the one needed for an unbound path. It's racing in from Sagittarius, hitting perihelion on October 29, 2025, at 1.36 astronomical units from the sun, zipping at 68 kilometers per second, about 152,000 miles per hour. The close calls are real. It brushes past Mars on October 3, 2025, at 0.19 astronomical units, 30 million kilometers. Close enough for NASA's rovers like Perseverance to potentially snap images from the red planet. Then Venus on November 3rd at 0.65 astronomical units, Earth on December 19th at 1.8 astronomical units, no threat, folks, and Jupiter on March 16th, 2026, at 0.36 astronomical units. These encounters are statistically rare for a random interloper. Calculations by astronomers like those at Harvard suggest the odds are low, but not impossible in our vast cosmos. Here's the plot thickener. At perihelion, 3I/ATLAS will be directly behind the sun from Earth's view, hidden by glare. Telescopes like Hubble and JWST can't peek through that. Fact. But spacecraft at Mars, MAVEN, Perseverance, or Jupiter, Juno, might offer side views. This alignment isn't calculated malice. It's orbital mechanics. Still, it builds suspense, doesn't it? As we move to implications, think of this trajectory as a grand tour, slingshotting like NASA's Voyager missions, but naturally orchestrated by gravity. If 3I/ATLAS is a natural comet, and all evidence points that way, its implications are profound yet grounded. Fact: studying its deuterium to hydrogen ratio in water could reveal if it formed around a star unlike our sun, offering clues to galactic planet formation. Its ancient age means it might harbor primordial dust grains, untouched for billions of years, transforming our understanding of the Milky Way's early chemistry. On the flip side, speculation enters. What if anomalies like the initial lack of gas or the precise planetary flybys hint at something engineered? Harvard's Avi Loeb has proposed checking for non-gravitational acceleration, extra push not from outgassing. If detected, it could echo Oumuamua's mysteries. But facts separate here. Current data shows typical cometary behavior, with no confirmed unnatural acceleration. Implications for planetary defense? It's a perfect drill. Fast, massive, uninterceptable with today's tech, but no real threat as per NASA. Dramatically imagine the payoff. This visitor could rewrite textbooks, proving interstellar material exchanges shape worlds like ours. But let's not leap to aliens without evidence. That's the thrill of science, patient pursuit amid cosmic wonder. The astronomy community is abuzz, and rightly so. Fact: most experts from NASA to ESO classify 3I/ATLAS as a natural comet, bolstered by its coma, emissions, and orbit-fitting interstellar ejection models. Debates center on its unusual nickel without iron, verified but explained by unique composition, and the anti-tail, a known phenomenon in comets like C/2023A3, Tsuchinshan Atlas, from 2024. Enter the speculative edge. Avi Loeb's papers suggest monitoring for artificial signs, like if it's a probe deploying mini devices near planets. He rates it on a 0 to 10 alien tech scale, but acknowledges it's likely natural. Critics like David Kipping counter that anomalies are overhyped. Better data from JWST will clarify. No gas initially? Early distance explains it. Activity ramped up as expected. This debate echoes past ones. Oumuamua's acceleration, thermal, not alien, and Borisov's fragmentation, structural weakness. 3I/ATLAS fits the pattern. Interlopers challenge models, but science adapts. Culturally, it unites us in curiosity, much like how Oumuamua sparked global interest. Beyond Labs, 3I/ATLAS taps into our collective imagination. In a world of streaming epics and space races, it's a real-life interstellar tale. Fact: media buzz, from YouTube breakdowns to Reddit threads, reflects our fascination with the unknown. It reminds us of humanity's exploratory spirit, NASA's drills, ESA's future interceptors like Comet Interceptor in 2029. Speculatively, it fuels stories of cosmic neighbors, but grounded in culture. Like ancient comets seen as omens, this one inspires awe without alarm. In 2025, amid climate talks and AI booms, it humbles us. Earth is just one stop on its eternal journey. As 3I/ATLAS streaks away post-perihelion, re-emerging in December 2025, we'll watch for outbursts or fragments, facts that could reveal its core. Whether it shatters like Borisov or sails steady, this 7 billion-year-old nomad has already ignited wonder. It's not a threat, not a craft, just a reminder the universe is vast, mysterious, and full of surprises. Friends, if this cosmic adventure gripped you, smash that like button, subscribe for more deep dives, and turn on notifications. New data drops soon. Comment your thoughts below, and stay tuned as we unravel more. What do you think? Natural wonder or something more?